To break even in sports gambling, the gambler must predict 52.38% of the games correctly. A certain statistician developed a program that correctly predicted 656 games out of 1,205 games versus the spread. At alpha equals 0.10, can we say that using this program, a gambler should predict at least 52.38% of the games correctly? Use StatCrunch here. Before we start the problem, let's check the conditions. There are two conditions. Condition number 1. We need to check that NP times 1 minus P is at least 10. N is the sample size. N is 1,205. And P is the population proportion. And here we're predicting 52.38%. As a decimal, that's 0.5238. Let's plug in the numbers into the formula. 1,205 times 0.5238 times the quantity 1 minus 0.5238 yields a value of 300.6, and that's clearly greater than or equal to 10, so condition 1 is met. Condition 2. We're going to write a sentence. The sample size is less than 5% of the population size. We can assume the population size is at least, and we're going to look at the sample size. The sample size is 1,205. We take that number and multiply by 20. This yields a value of 24,100. So we can assume the population size is at least 24,100. The conditions are met. Now we can start the problem. The claim. Using this program, the gambler should predict at least 52.38% of the games correctly. The claim is the proportion is at least, so we're going to use the greater than or equal symbol, at least 0.5238. Now the complement to that is the opposite, so we're going to say P is less than 0.5238. In step 1, we have to decide which one's the null hypothesis and which one's the alternative hypothesis. Remember, the null hypothesis is the one with the equal symbol. So we're going to say the null hypothesis is P is greater than or equal to 0.5238. The alternative hypothesis is the complement in this case, 0.5238. P is less than 0.5238. Step 2, state alpha. Alpha is 0.10. Step 3, we are going to state our test statistic, and for that we're going to go to StatCrunch. Let's try the problem now on StatCrunch. Go to Stat, Proportion Stats. Since we're doing a one sample proportion statistic, let's go to one sample with summary. We'll look at the number of successes. In the problem, it claimed there was 656 games out of 1,205. So there are 656 successes out of 1,205 games. We'll click hypothesis test, and P is equal to the null hypothesis, which is 5238 or 0.5238. Recall from homework and exams, they always use an equal sign for the null hypothesis. For the alternative hypothesis, we're going to use the less than symbol. And let's compute. Now we have our z statistic, which is 1.43. That's required in step 3. And our p-value from step 4 is going to be 0.9239. Z is equal to 1.43 from StatCrunch. Step 4, the p-value, and since we're doing this on StatCrunch, we get the value 0.9239. In step 5, we're going to state our conclusion. Ask yourself, is the p-value less than alpha? Is 0.9239 less than alpha 0.10? The p-value is not less than alpha. We do not reject the null hypothesis. There is not enough evidence to conclude, and remember, our conclusion is always in terms of HA. The alternative hypothesis was P was less than 0.5238. So we're going to say we do not reject the null hypothesis. There is not enough evidence to conclude the gambler should predict less than 52.38% of games. Nexium is a drug that can be used to reduce the acid produced by the body and heal damage to the esophagus due to acid reflux. The manufacturer of Nexium claims more than 94% of its patients taking Nexium are healed within 8 weeks. In clinical trials, 213 of 224 patients suffering from acid reflux disease were healed after 8 weeks. Test the manufacturer's claim at alpha equals 0.01 level of significance. Use StatCrunch share. Still have to check the conditions in this problem. The first condition is NP times the quantity 1 minus P has to be at least 10. The sample size in the problem is 224 patients, and P is the population proportion, which is 94% or 0.94. We'll plug in the values. 224 times 0.94 times the quantity 1 minus 0.94 equals a value of 12.6, and that's clearly greater than or equal to 10. Condition 1 is met. Condition 2, we just have to state that same sentence we've been using. The sample size is less than 5% of the population size. We can assume the population size is at least, and we'll take the sample size, which is 224, and we'll multiply that by 20. This yields a value of 4,480. We can assume the population size is at least 4,480. Condition 2 gives us the independence assumption. We're assuming the sample comes from a population that's independent from one another. Since all the conditions are met, we'll start the claim. The claim in this case is that more than 94% of the patients taking Nexium are healed. P is greater than 0.94. The complement is the opposite of this, so P is less than or equal to 0.94. Step 1, we'll decide which one is the null hypothesis. In this case, the null hypothesis is the complement because that's the one with the equal sign. The alternative hypothesis is P is greater than 0.94 since this one does not contain the equal sign. Step 2, we'll state alpha. Alpha is 0.01. For step 3, we'll go to StatCrunch and figure out what our test statistic is. Let's try the problem on StatCrunch. Go to Stat, Proportion Stats, One Sample with Summary. Stats, Proportion Stats, One Sample with Summary. The number of successes, we concluded there were 213 successes out of 224 patients. The null hypothesis was P was less than or equal to 0.94. Recall on StatCrunch and on homework, they always use an equal sign for the null hypothesis. And the claim is going to be greater than 0.94. Let's compute. And our Z statistic in step 3 is going to be 0.686. Our p-value in step 4 is going to be 0.2462. Z is equal to 0.682. Also from StatCrunch, we have the p-value in step 4 is equal to 0.2462. And finally, in step 5, we will state our conclusion. I'm going to ask the question again, is the p-value less than alpha? Is 0.2462 less than 0.01? No, it is not less than. We do not reject the null hypothesis. There is not enough evidence to conclude. And recall, the conclusion is always in terms of HA. We're going to state HA in words. There is not enough evidence to conclude the percentage of patients healed is more than 94%.